Welcome to MOVITRAC LTP-B Basic and Intermediate Training. This is Session 7. In our last session, we learned a lot about terminal control mode, which gives you some very sophisticated ways of controlling your VFD. As I said at the end of that session, we hadn't exhausted terminal control mode and would need a second session to cover it. So that's what we're going to do in this session, and even so, we're still not going to cover everything. Terminal control mode is actually a very rich and sophisticated mode, but by the time we're done, you'll have the outline of all the key ideas at least. So let's go ahead and learn a few new things about terminal control mode. We're going to start by talking about push button control, controlling the VFD with buttons rather than toggle type switches. Let's establish a few big ideas here of push button control. First of all, push buttons are momentary switches that generate edges or transitions between low and high or high and low when they're pressed. So a regular on-off switch, you turn it on, it generates a high signal and it stays high until you turn it off when it goes back to low. A push button is momentary. It's predominantly one level and it briefly transitions to the opposite level when you press it, but then when you release it, it goes back to the original level. There are two types of momentary switches. The first is called the normally open, often abbreviated NO. A normally open push button is open when not pressed, and it generates a rising edge followed by a falling edge. You can see the schematic symbol down there. It shows clearly that a normally open switch is open when you're not touching it. That means it's outputting a low signal. When you press it, you get a rising edge, and when you release it, you get a falling edge. The second type of push button is the normally closed or NC push button. It is closed when not pressed. When you press it, it's open. It generates a falling edge followed by a rising edge. Again, you can see the schematic symbol there. A normally closed switch is closed when you're not touching it, so it's normally high. When you press it, it goes low, so you get that falling edge, and then when you release it, it goes high again, giving you a rising edge. Now, why is this important in control? Very simple, the VFD responds not to the on-off conditions, not to the highs or lows, it responds to the transitions, to the edges. The VFD is watching for the transitions and it's going to do something when it detects an appropriate one. To make this clear, we're going to look at variant number 21 of terminal control mode. This is what's called the forward stop reverse variant. This variant uses 3 push buttons to control the VFD's operation and direction. So you would connect up your push buttons to the I/O connector on the front. Here they are. You have a red stop button in the middle and 2 green buttons that control direction. So these 3 buttons control the VFD's direction and they stop it, but they're all push buttons, not toggle type switches. This is how they're wired up. The 2 arrow buttons, which are forward and reverse, are normally open buttons. You connect them up to the 24-volt supply and then to digital inputs 1 and 3. The stop button is also connected up to 24 volts and it's connected to digital input 2. Now, you may wonder, why do they use normally open switches for the direction control and normally closed for the stop button? The answer is this creates what's called a fail-safe arrangement. What that means is if something goes wrong, for example, the 24-volt supply fails or a wire gets cut, the VFD will not enter into a dangerous operation mode. It will enter into something that is safer. In other words, it will fail safely. So for example, if that 24-volt supply fails or the power gets cut, what will happen is the VFD, if it's running, will stop because that normally closed stop button will appear to have just opened. And stopping the VFD is usually a safe thing to do. Also, the normally open forward and reverse buttons will not get triggered, and so they won't cause the VFD to suddenly and unexpectedly start. Now, no failsafe mode is perfectly bulletproof, but this at least eliminates some very obvious possibilities of dangerous failures. This is a diagram showing how the VFD would be handled using the push buttons. Notice that you press the forward button first. It detects the rising edge. The VFD would start up. It would run in the clockwise direction. Then a little later, the stop button is pushed. It creates a falling edge. That stops the VFD, brings it to a halt. Then a little later, the reverse button is pressed. It generates a rising edge, and the VFD runs in the counterclockwise direction. That is push button control. Pretty simple, Pretty logical. You've probably seen this in certain applications. So let's see how this variant is set up. Here are the signal assignments. Digital input 1 is connected to the start clockwise button. Notice it's identified with a normally open identifier. That just tells you what kind of push button you need. So we would push to start the VFD in the clockwise direction. Digital input 3 is the start counterclockwise button. It's also a normally open button. It's exactly like the one connected to DI1. The only difference is the VFD runs in the opposite direction. Digital input 2 is the stop button. It's normally closed, and you would push this button to stop it. Analog input 1 is connected up to a potentiometer, so it's operating in analog mode. That's used for speed control. And digital input 5 is a switch, an ordinary toggle type switch. If it's off, then the VFD will use the potentiometer as the speed reference. If it's on, it will use the value in preset 1. So let's look at an example here. First of all, if you push the switch connected to digital input 2, it will stop the VFD normally using the ramp in parameter 1-04. Now, if digital input 5 is off, we're going to be in potentiometer control mode, and if we push the button connected to digital input 1, it will start the VFD clockwise. The potentiometer will set the speed. If we push digital input 3 instead, the VFD will do the same thing, but it will run counterclockwise, but still use potentiometer control. And if digital input 5 is on, that will select the speed stored in preset number 1. If we press digital input 1, then that will start the VFD running clockwise. And of course, the same thing would happen if we press digital input 3, except it would turn counterclockwise. Pretty straightforward. All right, let's look at another push button control variant. This is variant number 10. This uses something called a digital potentiometer. We haven't used this term before, so I'm going to explain what it is in just a minute. This variant uses 3 switches, regular ones, just on-off toggle type switches, and 2 push buttons to control the VFD's operation and direction. So we would have a control panel sort of like this. We would have a run-stop switch, a forward-reverse switch, and a switch that would select between a set point speed and the potentiometer. And then we would have 2 up-down buttons that would control the speed. These buttons function as what's called a digital potentiometer. So instead of having a knob that you rotate, an analog device, this is a digital potentiometer. When you press the up button, it will increase the speed smoothly. If you hold it down, it will ramp up. And the down button does the opposite. It slows the VFD down smoothly if you push it. If you hold it, it will just keep going down. This is equivalent to controlling the VFD through the keypad up-down buttons. In fact, those are considered digital potentiometers as well. So you'll see that term applied both to terminal control mode and to the up-down buttons in keypad control mode. Let's look at the variant. Digital input 1 is a regular stop-run switch. It's basically an enable-disable. Digital input 2 selects the direction of rotation. Digital input 3 is a push button. It's a normally open push button, and you push it to increase the speed. Digital input 4 is also a push button, normally open, and you push it to decrease the speed. And then digital input 5 selects between the digital potentiometer if it's off and preset speed 1 if it's on. Let's look at a few examples here. If digital input 1 is off, doesn't matter what the other settings are, the VFD will come to a normal stop using the ramp in parameter 1-04. Now, if digital input 5 is off, that selects digital potentiometer mode. If you turn digital input 1 on, it enables the VFD. Digital input 2 selects clockwise rotation. And if you push digital input 3, it will increase the speed. The VFD will be turning in the clockwise direction, and the longer you hold the button, the faster the motor will go. Now, in this example, digital input 1 is on, so the VFD is enabled. Digital input 2 is on. That selects counterclockwise rotation. Digital input 5 is off. That selects the digital potentiometer. So if we're turning, which would be in the counterclockwise direction, and we press the button connected to digital input 4, our speed would decrease. If we turn digital input 5 on, that selects preset speed. And if digital input 1 is on, digital input 2 is off, the VFD will run clockwise at the preset speed. Now, this last mode is kind of interesting. You might not know that it exists if you didn't delve into the documentation. If your VFD is running in digital potentiometer control mode, in other words, digital input 1 is on and digital input 5 is off, if you press both push buttons that control the digital potentiometer and you press them at the same time, the VFD will start to decelerate using the ramp in parameter 1-04. Now, if you let both the buttons up again before the VFD has come to a complete stop, it will just continue at whatever speed it's reached. But if it's gone all the way down to a complete stop and you let go of the buttons, it will stay stopped. If you leave digital input 3's button down, however, it will reaccelerate. So this is kind of a stop mode. It's also kind of a pause mode. It's something that only works in digital potentiometer control mode. If you're running with the preset speed, in other words, digital input 5 is on, won't happen at all. So this is kind of an odd one. You might want to play with this just to be sure you understand it, but I do want you to be aware it's in there, so if you should happen to push both buttons and see this happen, it won't startle you. Okay, I think it's time for a hands-on to play with push button control mode. So here's what I'd like you to do. I'd like you to go into LT Shell, and I'd like you to change to terminal control mode variant number 20. Then I'd like you to work out how it operates. You may have to dive into the documentation and look up this parameter, but it's pretty obvious. And then I'd like you to test the drive to confirm the operation with the digital potentiometer and also confirm that the preset speed works. Let me give you a hint. If you don't have push buttons connected to your demo unit, and that's perfectly fine, you can simulate their operation using toggle switches. What you should do is set the toggle switch to the push button's normal state. So if it's supposed to be a normally open push button, then turn the switch off. If it's a normally closed push button, turn the switch on. To simulate a push, all you have to do is flip the switch to the opposite position and then right back again. And that will behave exactly like a push button. So you can do that, or if you happen to have push buttons that you can connect up to your demo unit, that is fine too. In either case, pause the video and do the hands-on. All right, time to demonstrate this, and if you had any problems, hopefully this will clear things up. So first of all, let's look at variant 20 and see how it operates. Digital input 1 functions a little differently than you've been accustomed to seeing in the past. If the switch is off, the VFD stops, but if it's on, it runs clockwise. Digital input 2 is the same kind of control, but it runs the VFD counterclockwise if you turn it on. Digital input 3 and digital input 4 are your digital potentiometer buttons. They are normally open push buttons. Digital input 3 increases the speed if you push the button. Digital input 4 decreases the speed if you push the button. Digital input 5 selects between the digital potentiometer if it's off and preset speed 1 if it's on. If digital input 1 and digital input 2 are off, you get a normal stop using the standard deceleration ramp in parameter 1-04. The other switch conditions are unimportant, they're ignored. Now, if digital input 1 is on, that selects clockwise rotation. Digital input 2 must be off. Digital input 5 is off, that selects the digital potentiometer. And if you press the button connected to digital input 3, that will increase the speed and it will rotate clockwise. If you have exactly the same arrangements, but you push the button connected to digital input 4, the VFD will slow down, but it will still be turning clockwise. If digital input 1 is off and digital input 2 is on, you will get counterclockwise rotation. And since digital input 5 is turned on, you will get the preset speed. So the digital potentiometer buttons will be ignored in this mode. And this is a little extra. You have to delve into the documentation to discover this one. If you turn digital input 1 and digital input 2 on at the same time, which seems contradictory, you're telling the drive to run in both directions at once, you will get a fast stop using the ramp in parameter 2-25. The other switch settings do not matter. It will fast stop the VFD. If you didn't discover that one, that's okay, but now you know about it. And then we have another little bonus here. If digital input 1 is on, digital input 2 is off, and digital input 5 is off, that normally selects digital potentiometer controlled rotation in the clockwise direction. However, notice we're pushing both the up and the down speed control buttons at the same time. If you do this, the VFD will decelerate the motor using the standard deceleration ramp in parameter 1-04. If you hold the buttons down long enough, it will actually bring the motor to a complete stop. If you let them up while the motor is still decelerating, then it will resume operation. This is similar to what I called stop/pause mode that we looked at earlier in this session. So again, you might not have been aware of that unless you dug into the documentation, but it's there, and it is another way to control the VFD. All right, now I'm going to go into LT shell. I'm going to set all this up, and then we'll go ahead and demonstrate it. Well, we're in LT shell here, and the first thing, of course, that we always do is scan into the network, and we found our drive, of course, no big surprise there. It's the same configuration as in our last session. We're in terminal control mode variant 8, and we're going to have to switch it to 20. So the first thing, of course, we always do is we turn on real-time edit mode. And then we go to parameter 1-15, and we change it from 8 to 20. There we go. That's all we have to do, so we're going to disable real-time edit mode, but I do want to point a few things out by way of reminder. First of all, parameter 1-04 is set to 4 seconds. That's our normal deceleration. And we go to group 2, parameter 2-01, preset 1 is 100 RPM. We'll be using that preset, and then parameter 2-25, our fast ramp is 2 seconds. So the fast ramp is twice as quick as the normal deceleration. We'll be playing with both ramps. And that's all we have to do, so let's go in and play with our drive. All right, well, we've got everything set up. Now we're ready to demonstrate it by working through the different possibilities. As you can see on my VFD, I do not have push buttons, so I'm going to simulate them using the toggle switches and also the potentiometers. Remember, the potentiometers, if they're turned all the way down, look like an off switch, and if they're turned all the way up, they look like an on switch. So I'll have to do that. It's a little awkward and clunky, but I think you'll get the idea. Okay, before we begin, I just want to point something out. Digital input 5 selects between the digital potentiometer and the preset speed. This happens to be a real potentiometer on my VFD. Notice it's turned all the way down, so that's the off position effectively. So right now we've selected digital potentiometer mode. Okay, so here we go. The first thing I'm going to do is turn digital input 1 on. That will enable clockwise rotation. Notice we're not turning yet, but now I'm going to pulse the up button, which is digital input 3. I'll just flick it on and off quickly, and you can see, there we go. Our digital potentiometer is increasing our speed. If I leave the switch turned on, which is like holding down the button, it just goes all the way up to the maximum. All right, now we'll come down. I'm going to rotate the potentiometer on digital input 4, and I'm going to flick it back and forth, so it's kind of going on and off, and you can see we're decelerating, so the digital potentiometer there is going down. All right. Now let's disable that and go counterclockwise by turning digital input 2 on. We'll do the same thing. We'll pulse our imaginary push buttons here, and we'll ramp our speeds up and down. So you can see that works pretty well. It would work better with push buttons, of course. Now we're going to activate our preset speed, preset 1, which is 100 RPM. I've got to turn digital input 5's potentiometer all the way up. And you can see just turning it on and off with digital input 1 or 2, we get the preset speed, and that's it. All right, let's go back to digital potentiometer mode by turning DI5 to the off position, and we're going to play with those 2 stop ramps. So what I'm going to do is accelerate all the way up to 1800 RPM, and we're going to do a normal stop first. So I'll turn digital input 1 off. And you can see that definitely took a few seconds. And now I'm going to go back to my maximum speed again. And I'm going to turn digital input 1 and digital input 2 on at the same time, which triggers a fast ramp. And you can see it did stop a lot quicker. Now let's go up to top speed and let's press both push buttons simultaneously. That's going to be a little tricky since they're not actually push buttons, but I will attempt it here. And you can see there I just triggered a normal stop. It's clearly taking the full time to stop there. So it was longer than the rapid stop, obviously. And that's it. Okay, well, now we're going to move on to another aspect of terminal control. I mentioned this briefly in our last section, and that is custom terminal control. As you may recall from that section, I said there were a total of 27 different terminal control variants, 26 of which are predefined, and one of which is totally customizable. Well, the time has come to look at the totally customizable form. So how do we switch to custom terminal control mode? It's really easy. You just go to parameter 1-15 in the basic parameters, which selects the control variant, and set it to 0. And that puts you into custom control mode. Now, from this point on, you do everything else in parameter group 9. Parameter group 9 exists solely for configuring the custom terminal control mode. We haven't been in this tab before, but we're going to spend a lot of time in it right now. I'm going to give you a little tip here. You will find this a lot easier to work with if you do it in LT Shell rather than using the keypad to create custom configurations. You can certainly use the keypad if you wish. There is no loss of functionality, but you will find it a lot easier if you use LT Shell, and that's what I'm going to do. Now, a very big idea here. Custom terminal control mode is complicated, and I'm not exaggerating this. It is a sophisticated and tricky mode to use. We are only going to scratch the surface, otherwise this class would become ridiculously big. But I think what you'll learn in this session will enable you to get a good grip on it, and you'll be able to play with it on your own and use it to best advantage. So how does custom terminal control mode work? Well, it basically involves assigning different speed sources and control signals so the VFD will behave in a specific way. Now that sounds innocuous on the surface, but what does it really mean? Well, I think a diagram's in order to help make things clear. First of all, there are 8 locations within the VFD that hold different speed sources, things that tell the VFD how fast to run. Think of them as slots in the VFD's memory, and each one of them can be populated with one speed control source. Here's a master list of all the speed sources, and I think some of these probably look familiar to you. You notice analog input 1, that's one of the inputs that's often connected to a potentiometer. You also see the 8 familiar preset speeds, and then a whole bunch of other sources. What you do is you pick these different sources, you put them in the 8 speed source memory locations, and the VFD will then use these in custom terminal control mode to control its speed. The fixed set points, of course, are part of this. There are 8 of these, and as you already know, they come from parameters 2-01 through 2-08. And then we have various VFD functions. Now, this is not an exhaustive list, but it's a list of all the ones we're going to talk about in this session. A lot of them, I think you can guess what they do. And what we do is we associate these signals with all of these different operations. You notice we have our digital inputs here. We also have off and on. By the way, you may be a little puzzled to notice that there are 8 digital inputs listed when you know that the VFD only has 5. Well, if you want to use digital inputs 6, 7, and 8, then you have to install one of the I/O expansion cards. If you don't have that card installed, obviously you can't use those last 3 inputs. Now, these inputs are tied to just about everything. You use them to pick the speed sources, you can use them to pick the fixed set points, and you can use them to activate or deactivate the different VFD functions. You can see this is a little bit complicated. Remember I said terminal control mode is very sophisticated. And this is probably a good time to give you a little warning. The VFD does not check your setup for custom terminal control configurations as far as suitability or safety. It is totally possible to create a configuration that does something undesirable, unexpected, or even unsafe. So, test all custom configurations thoroughly, and if you're in any doubt about how something works, check the manual. So you have been warned. All right, so let's go into this section by section. We'll first of all talk about how you set up these speed sources, how you assign them. As I said, there are 8 locations in memory of the VFD. They're held in parameters 9-10 through 9-17. Each one of these can contain a single speed source. So here they are. They all default to analog input 1, but of course you're going to change these and you use the little pull-down boxes to do this. Just a note here, every single source must have an assignment. You aren't allowed to not assign something, but you do not have to use every source. So if you're not using a source, you can set it to whatever you want. It's perfectly fine. As you can see, they all start by defaulting to analog input 1, which is a safe thing to leave them set to if you wish. These are the things that you can pick. I'm going to explain what most of them are, although not all of them. Some of them are really part of advanced control modes, and we're not going to go into them in this class. We'll start with analog input 1 and analog input 2. These are the two inputs on the VFD. They're typically connected to potentiometers. They could be connected to some kind of variable voltage from another source, but these are usually used for speed control, so you can pick one or both of them if you wish to even have, say, two potentiometers. It's up to you. Then there's the keypad. That's the up-down buttons on the front of the VFD, so you can actually sort of blend keypad control mode with terminal control mode by using this option. There is the field bus, where you receive a speed over the field bus from a PLC or other digital controller. We won't be getting into that in this session, although we will be looking at field buses in a later session. And then, of course, our 8 preset speeds, which are stored in those parameters found in Group 2. You can assign any one of these to any speed source you like. Now, you may be a little puzzled, wondering, well, what's number 2 then? It's also labeled preset speed. Let's just table that for now. I'm going to come back to this later. This is actually a very clever feature that's available that allows you to have more than 8 speed sources. We will look at that at the very end of this session. Okay, so that's our speed sources. So now we need to move on to setting up control signals to tell the VFD what to do. There are many parameters in Group 9 that are used for these functions, so I'm not going to be able just to give you a range of them. Instead, what I'm going to do is show you the VFD functions and the parameters associated with each one of these. So what you must do to invoke these functions is you must associate a signal with each VFD function that you wish to use. You do it through their parameters. These are the choices available for everything but the very first function on this list, which is enable. So notice you can assign any one of these to a digital input, 1 through 8, or you can just turn them permanently on or permanently off. Now the enable function is a little bit different here. It has these choices, and you notice the differences. Notice that there is no on or off for the enable function, but there's a different option called safe. The reason for this is because the enable function is sort of a mandatory function. You can't use the VFD without it. So you can either use a digital signal to enable it, or you can set it up by setting it to safe so that the VFD is enabled when it is not in safe torque off mode. Remember, on our demo unit, we have 2 switches that enables or disables safe torque off mode. When we're not in that inhibit mode caused by those signals, if we wish, we can have that also enable our VFD. But if we don't want to do that, of course, we can pick one of the 8 digital inputs. All right, now a note here, this is rather interesting. It is possible to have one of those digital signals, digital input 1 for example, activate multiple functions. For example, you could have digital input 1 activate the enable and the run function. So you could assign it to parameter 9-01 and 9-03. That would be legitimate. When you activate that digital signal, it could enable the VFD and start it running. So it is possible to have a digital input control multiple functions, but you've got to be very careful here. You clearly do not want the digital input to try to activate 2 things whose operations are mutually exclusive. So again, be careful. All right, let's talk about what these different functions do. We'll start with enable. This one, of course, is mandatory because the VFD can't run without it, so you've got to either set it to a digital input or set it to the safe function and let the safe torque off control it. Terminal override is also mandatory. You need to either set this to on all the time or assign it to a digital input. If you don't turn it on or have a digital input turn it on, then terminal control mode doesn't even activate and the VFD will just ignore everything you do. If you forget to set this to on or assign it to a digital input, you may be wondering why your terminal control mode isn't doing anything. That's the reason, so don't forget terminal override. All right, now the forward run can be used either as a generic run signal or you can pair it with the reverse run. So you can either have two signals controlling direction in this way, forward and reverse, or you can use forward run by itself as a generic run signal, and then if you want to control direction, you can use reverse enable, which functions as a forward reverse signal. It's up to you. Jog clockwise and jog counterclockwise activates a jogging speed. It uses preset 1, which is parameter 2-01. Usually jog speeds are set to fairly low RPM values, but of course that's fully within your control. So you can use this for jogging the VFD in one direction or both. Reset allows you to use a digital signal to reset any VFD faults. External trip is something we'll look at in a later session. It's used for monitoring external sensors. Fast ramp enable uses the fast ramp, which is in parameter 2-25 for all decelerations if you activate this function. And I'll just also mention here, if you aren't going to use a function, set it to off. So all unneeded functions should be turned off. Continuing on, parameters 9-18 through 9-20 in group 9 associate control signals with source selections. Remember, we have all those speed sources. We've got 8 of them. Well, it takes up to 3 digital inputs to select them all. We need to supply a 3-bit binary number to pick these. Parameter 9-18 is the least significant bit. 9-20 is the most significant bit, so these form a binary number. We need to assign digital inputs to allow us to generate that number. If you don't need to use all 3 bits, you can set a bit to either permanently on or off rather than assigning it to a digital input. But if you want to control all 3 of them freely, then you'll need to assign them to digital inputs. These are the patterns that will pick your sources, just straight binary numbers, nothing fancy here. This should be familiar if you're comfortable with binary. Again, if you're not, you might want to go out and find a YouTube video to review how binary works. When you're working with VFDs, you've got to be pretty comfortable with small binary numbers. Now, an important note here, and I think you've probably already kind of guessed this, the limiting factor in custom terminal control mode is the available I/O signals. There are only 5 built into the VFD, or if you put the expansion card in, you can have 8. That's still not a whole lot. It's very easy to run out of digital inputs. And if you run out of them, then you won't be able to do certain functions. So it takes some creativity to work with digital control in this way. All right, I think it's time for a demonstration to help cement some of these concepts. Let's do an example. I've just created a custom setup here, and I'm going to show you how to implement it. Here's what the inputs will be set up to do. Digital input 1 is going to be a stop run clockwise signal. So when it's off, it will stop the VFD, and when it's on, the VFD will run clockwise. I'm going to use digital inputs 2 and 3 as bits to select from one of 4 total speed sources. So we're only going to use half our speed sources. Analog input 1 is going to be a speed control potentiometer. So this is the one input that's going to be put in analog mode. And then digital input 5 is going to select between either normal ramps or fast ramps. So if it's off, we'll get normal decelerations, and if it's on, we'll get fast ones. So with digital inputs 2 and 3, we'll have these 4 possible patterns, and this is what I'd like them to select. If you put a 0, 0 in, then we'll get the potentiometer as our speed source. If you put a 1, 0, we'll get our keypad. If you put a 0, 1, we'll get preset speed 1, and if you put in 1, 1, we'll get preset speed 2. So the least significant bit is digital input 2, the most significant is digital input 3. That means the binary pattern is sort of backwards. But you're used to that by now. Shouldn't be a big surprise. So that will select our sources. So how do we go about setting this up? We'd go to parameter 9-10 through 9-13, and we'd set the speed sources up to reflect those requirements. So you can see speed source 1 is the analog input 1, that's the potentiometer. Speed source 2 is the keypad. Speed sources 3 and 4 are preset speeds 1 and 2. And the last 4 sources aren't used, so we just leave them set to the defaults analog input 1. They never actually get access, so it doesn't really matter what they're set to. So that's how we set up our sources. Then we need to pick some digital inputs to select those sources. Since we're only using 4 of the sources, we don't need all 3 bits. Parameter 9-18 and 9-19 are set to digital inputs 2 and 3. And notice parameter 9-20 is set to off. So in other words, it's permanently set to a 0. That means those upper 4 sources can never be selected. And that's why it doesn't matter what they're set to, because they're basically inaccessible now. And then finally, we need to assign some digital inputs to the different VFD functions. We're going to let our VFD be enabled by the safe torque off signal, so we'll set this to safe. That means when the VFD is not disabled by safe torque off, it will be enabled. We will set terminal control override source permanently to on, so we're always in terminal control mode. If we forget to set this, nothing will work. And then we'll set parameter 9-03 to digital input 1. This is the forward run input source. That means the VFD will run clockwise when this signal activates it. And we will set parameter 9-32, the fast deceleration ramp, enabled to digital input 5. That will allow us to select between our normal and fast ramps. Everything else is set to off, so nothing else can activate. And that's just what we want. All right, so let's go into LT Shell. I'll show you how to set this up and then we'll test it. All right, well, let's go build ourselves a custom configuration. We need to get back into our drive, so I'll scan into it. We're right where we were last time using variant 20. So what we're going to do is enable real-time edit mode. And then we're going to first of all change parameter 1-15 to 0, which allows us to have a custom defined terminal control mode. Now everything else we have to do from this point on takes place in group 9. So we're going to change to group 9's tab here. And we're going to go ahead and set a variety of things. First of all, we'll set our speed sources. So we'll go to parameter 9-10. Which is our first speed source, and we'll set it to analog input 1. That's the potentiometer. Actually, it defaulted to that, so we didn't really have to change that. We'll change the second speed source to the keypad, so we'll be using the up-down buttons on the keypad to control it if we have this speed source going. And then we'll set the next 2 to preset speeds 1 and 2. And we're going to leave the remaining 4 sources just to the default value of analog input 1 because we're not going to use those. So that's our speed sources. They're all set. The next thing we have to do is we have to set up digital inputs that can activate these sources. So we're going to roll our way down here and we'll go to parameter 9-18. This is the least significant bit that selects the speed source. I'm going to assign this to digital input 2. I'm going to set the next bit to digital input 3. And I'm going to make sure the top bit is turned off because we're not using it. So that way we can only enter patterns 00, 01, 10, and 11. All right, so now we have our sources able to be selected. The last thing we have to do is set up a few VFD functions. We'll go back up here. The very first thing we need to do is be sure the terminal control override source is set permanently to on. Otherwise, we won't even be in terminal control mode and nothing will happen. So I'm just going to turn that permanently on. I'm going to make the enable the safe torque off rather than giving it a digital input. So it's already set to safe. I'm just going to leave it on that. And then we have to set parameter 9-03 run forward input source to digital input 1. This will tell the VFD to run, and it will run in the clockwise direction. And then I have to go way down here to parameter 9-32. This is the fast deceleration ramp enable. Right now it's turned off. I'm going to set it to digital input 5. And that'll allow us to select between 2 different ramps. And then I'm going to just confirm everything else has been switched off that we're not using. We have lots of offs here. We'll kind of go up here, check again. Everything else is off, so we're good. So that's everything. We're now set up in our custom configuration and we're ready to test it. We'll turn off real-time edit mode and jump over to our VFD and exercise these functions. All right, let's go ahead and test our custom terminal control variant here. I've got my VFD up and running, and I'm ready to work through those different combinations, and we can see what happens. All right, just by way of review, let's remember that digital input 1 is our run and stop switch. Digital inputs 2 and 3 are the bits of our speed select switch. Digital input 4, which is the potentiometer, is actually a potentiometer. It will be a speed control source. And digital input 5, which is a potentiometer 2 on my demo unit, is actually being used to select between the two deceleration ramps. When it's off, we get the normal ramp. When it's on, we get the fast ramp. Right now it's off. All right, so we're going to go ahead and start. We're going to turn digital input 1 on. Notice digital inputs 2 and 3 are off, so that's speed source 1. That's going to be our potentiometer. So let's do it. So you can see we're enabled, but we're not turning yet. That's just because the potentiometer is all the way down, so I'll turn it up. You can see we're running, and I'm turning it back down. So that's our first source. Let's turn digital input 2 on to pick our second. That's the keypad. Re-enable the VFD, and I'll press the up button on the keypad, and you can see it's controlling the drive now. Let's decelerate back down. So that's our second speed source. We'll disable things, and we'll turn on our third by turning digital input 3 on. And I'll re-enable the drive. Now this is our preset 1, which is set to 100 RPM. That's okay. And finally, our last source, our second preset, 250 RPM. And that works. So now we'll again disable our drive. We're going to test out the ramps now. So we're switching back to potentiometer control mode. I'm going to turn it all the way up, so we'll go at our top speed, 1800 RPM. Now let's decelerate. We're on our normal ramp because digital input 5 is off. You can see that did take some time. Now we're going to turn digital input 5 on by turning the potentiometer all the way up, re-accelerate to 1800 RPM, and come down. And you can see that took only about half the time, so clearly we do have our two ramps working just fine. So it appears our custom configuration works as we expected. All right, we're almost done. This has been a very long session, but I have one more thing to show you before we wind up terminal control mode. You've seen the power of creating a custom configuration, and I'm going to show you something even more powerful, and that is how to have more than 8 speed sources. Now, in most applications, you're probably not going to need that many, but sometimes you might. So I'm going to show you an example of how you can get 11 speed sources, even though there are only 8 locations in memory to hold speed sources. I will mention, though, that you need an I/O expansion card to access this, and since I don't have one in my demo unit, I can't actually show it running. But I can show you how to set it up. So let's talk it through. I'll go into LT Shell, show you the setup, but alas, I won't be able to actually demonstrate it running. So here is our more than 8 source configuration. You notice we're using 8 digital inputs here instead of the usual 5. One of them is an analog input 1. Everything else is digital. So digital input 1 is a stop run signal. Digital inputs 2 and 3 select between one of 4 speed sources, and you may be wondering, how do we get 11 out of this if we can only select 4? Well, just hang in and you'll see in a minute. Analog input 1 is set to the potentiometer, so that's a speed control source. Digital input 5 selects the direction of rotation, either clockwise or counterclockwise. And digital inputs 6, 7, and 8 form a 3-bit binary number to select one of 8 fixed speed set points. I think maybe now you're getting a hint of how we're going to get these 11 speeds. We have 4 speed sources and 8 fixed speed set points. Now that, as you know, if you add those up, equals 12. So why is it only 11? Again, hang in there. This is kind of interesting. So here's what we're going to do. If we put these patterns in here, 0, 0, 1, 0, 0, 1, 1, 1, we select between the keypad, the potentiometer, the field bus, and one of our presets 1 through 8. And if we activate that option 1, 1, presets 1 through 8, then the pattern presented on digital input 6, 7, and 8 will pick one of our 8 set points. So you can see the patterns for those. So basically we have those 8 presets all packed into that one option pattern 1, 1 on digital inputs 2 and 3. So that's 8 possibilities there, and then we have field bus, potentiometer, and keypad, total of 11. Okay, so you see how that works? Let me show you now how we're going to implement it. And this comes back to that preset option that I told you to table a few minutes ago. We're now going to look at how to use it. So let's go ahead, back into LT Shell and demonstrate it. Okay, well, let's set up our last example of a custom terminal control mode configuration. Again, we're back in LT Shell, and I'm going to rescan into my drive. And I'm going to enable real-time edit mode. Now, we are already in a custom configuration from last time. What I'm going to do is kind of interesting. I'm going to change parameter 1-15 from 0, which is user-defined, back to just type 1. That's one of our predefined variants. And then I'm going to change it back to 0, user-defined. The reason I do this is every time you switch in and out of user-defined, it resets all the parameters in group 9 back to their defaults. That is really handy since we made a lot of changes last time and I don't want to have to go undo a lot of those. I'd rather just start with a clean slate in group 9. So we're all set. So I changed to the Group 9 tab, and we're now going to set up our custom configuration, which will give us access to 11 different speed sources. So let's set up the speed sources first. We'll go to parameter 9-10, which is our first speed source, and we'll change that to the keypad. We'll change the second speed source to the potentiometer, and actually it's already set to the potentiometer, so we don't have to change it there. We'll just leave it set to analog input 1. We'll change speed source 3 to the field bus. And then finally, speed source 4 is kind of the magic one. This is the one that's going to give us access to all 8 of our presets. And here's how we do it. Instead of picking one of the preset speeds down here, what I'm going to do is pick this option, number 2 up here, that just says preset speed. Now what's going to happen when I select this speed source, preset speed, it will mean whichever of the 8 presets I select using an additional 3-bit binary number. So you can think of option 2 here, preset speed, as kind of a gateway to all the presets. Kind of handy. Okay, so now we need to set things up so we can select those 4 speed sources and all our set points. So I'm going to roll down here, and first of all, we're going to set parameter 9-18. which is the least significant bit of the speed source, to digital input 2. We'll set parameter 9-19, which is the middle bit, to digital input 3, and we'll set parameter 9-20, the most significant bit, to off. We're not going to be using the upper 4 sources. And then right below that, we have 3 bits where we can select our presets. So we're going to set parameter 9-21 to digital input 6. We'll set the next one to digital input 7 and the most significant bit to digital input 8. So between those 2 bits used to select the speed source and the 3 bits used to select the preset, we in fact will have access to 11 different sources. We're almost done, but we do need to configure the VFD itself to respond to the correct inputs. So let's go back up here. First of all, of course, we need to turn parameter 9-09 terminal control override source to on. That just permanently activates terminal control mode. We need to enable the VFD, and we're going to just let the safe torque off signal control that, so we'll leave this to the default choice of safe. We have to now change parameter 9-03 to digital input 1. This is the forward run input source. This will tell our VFD to run. And finally, we change parameter 9-06, which is the forward reverse control, to digital input 5. Everything else should be set to off. We just kind of skim down here and confirm it is, and everything is set up. So this, in fact, now will give us our completed custom configuration that will give us access to those 11 sources. And that is it. All right, and that is the end of session 7. We are done with terminal control mode. Yes, that was a very long session, and I commend you for hanging in there. But as you can see, you can do a lot with this VFD in terminal control mode. In our next session, we're going to move to some new topics. We're going to talk about some new ways to operate the VFD and control it, and I think you'll find them interesting as well. This is a powerful product, and I hope you're beginning to appreciate that. See you next time.